Swayam Prabha. Digital India. Educated India.
In the rapidly evolving world of power systems, innovation is not just an advantage, it is a necessity. Today we will have a conversation with the SIH 2025 winners, the minds behind a cutting-edge breakthrough, an AI and ML-enabled digital twin for EHV substations. Let's talk to the innovators who are transforming the future of energy management and making power systems smarter. Welcome to the studio, guys. To begin with, let's know something about you. Please introduce yourself one by one and let's hear about yourself then.
Hello sir, I am Karthik Prajapati. I am a final year CSC student. I am the team leader of Skylink and I worked on the AI/ML part of our project.
I am Verma. I am also in final year student at ADGIPS, affiliated with GGSRU, and I was the core part of the team in the project part.
My name is Manan Gakkar. I am a final year CSC student responsible for research and development of the project for electrical components and its presentation and pitch purposes.
Myself, Rohit Sharma. Currently, I am final year student at GGSRU University, and right now I am working with AITES as a software engineer.
Okay, great. So now coming to the SIH 2025. So tell me what your problem statement was. What exact problem was it that you worked upon?
So sir, our problem statement was that there are EHV substations throughout the cities which have complex equipments like transformers, circuit breakers, etc. They require continuous monitoring. Now the current system that the PGCIL had was scattered. There were different things to manage every independent thing. So we had to build a software that gives a unified view of the substation, and the project managers can view the complete substation from one single system.
What was the thing that was deployed currently? How were they, fighting with this issue at this juncture before you started working on that?
So currently they had SCADA systems and historical databases from which they used to manage all the software requirements. They used to see the data and identify things themselves, and they wanted someone to automate for them so that there is less need of manpower to manage the software.
Okay, now let's come to the solution that you offered. What exact solution did you work upon, and what exactly, how did it work exactly?
So sir, our solution was to build a digital twin, which is like a virtual replica of the substation. The solution was built on 3 layers. First, we had the data integration layer, which takes data from the currently different systems of the PGCIL, like the SCADA system, the sensors, and the databases. Then the second layer was the machine learning layer. We send all the data to the machine learning models, which identify anomalies and find if there are any problems that are going to occur in the future. And the third, we had the visualization layer. It was a website and the 3D model from where the workers can see the complete interface and they can manage the substation digitally.
Can you take us step by step into the working of it? How does one use it? How is a person at the substation would be benefiting in which manner?
Yeah, so this is the solution which we built for our Ujasati, and this is the homepage of the application. So if I'm coming to the solution, so this is the dashboard where we can see the real-time overview of all the census data and in the chart format, and they can easily change the format to their liking, like tabular format. They can change for 24 hours data or live data. So yeah, this was the chart thing, and then we get the 2D simulation for our substation, where they can simulate the behavior of substation based on weather and weather condition, stable condition, and it can also increase the speed of the simulation, so they can actually see how the simulation is working. And if we click on a particular component, we can see the status of the component and the live sensor data here as well. So this was the simulation part. Then we also made the 3D simulation where we can see the substation in 3D model. So this was a 3D model which we built for this substation. And if we click on any component, we can see the data for that particular component showing up like this. Then we had the ML alerts part where we can, where our ML model will be working on the data and check if there is any alerts which they can be generated. And then we have the task management part where we can create tasks from the dashboard as well, and we can send these tasks to the application which we also build. So this is the application which we built for the Uja Sathi, and this application was mainly meant for the workers who will be going to the substation, and they can open up the task and see if there is any inspection list which they can check, and if they complete, these will be reported to the dashboard. So yeah, this was the project which we did.
Okay, so it looks really wonderful there. Now tell me one thing. Let's get to know about the kind of research that went to in.
So the main thing which we had to do, like choose the tech stack which is appropriate for making a scalable application. So we went with InfluxDB for the database because it is a time series database, and we are dealing with a lot of time related data here because the data is coming from sensors in real time. Every second delay matters here. And for the website part, we used Next.js, and for the ML part of the application, we used TensorFlow. And more Karthik will be able to tell you about the ML part of the application.
So we had built AI and ML models that do two critical things. First was the anomaly detection, that the system automatically flags any unusual patterns that it sees in the data. For example, the temperature of the transformer is continuously increasing at random times. It will flag that the transformer is faulty and that it needs checking. So we used LSTM model for that. And second, we had built a predictive analysis model which will predict when the current equipment needs maintenance, so that it is becoming downgraded, so workers can go there and change the hardware so that it works correctly as it should.
Okay, so Rohit, you wanted to add something to it?
Yeah, so like Karthikeya will explain about the ML portion as we have developed that application also. So in our application, the main core was a worker previously handled all the data manually. They actually record on a paper, explain it to the superior that this is how the transformer working in real life. But as we have developed an application to solve this particular issue, our worker gonna be on the site and they can click a picture, and if the superior tells them or command them to make sure if those X and Y points are clear so they can move forward. They don't have to maintain a proper manual record. They just can go check the site, check all the reliability area, click a photo and send it to the superior so they can connect in a very superior and a fast way. So the transformer issues may resolve very quickly and very feasibly. They don't have to wait for a very long, but the application running smoothly through our area and very processly, and they can examine even small details very particularly.
So now talking about the competition that you went to, SIH 25. So when you were there, when you started working there in the competition itself, what kind of a journey was that? When you met the mentor and the judging rounds began, so were there any issues found by the judges? Was there any feedback which led to any changes? So tell us all about that.
As a CSC team background, we have faced a difficulty in electrical components and their dependencies. As in transformers, we were not fully have a knowledge about that electrical components and how they are dependent to each other. In initial rounds, we have faced some of the standard units measurements issues, and also the dependencies that were not handled by us that time. The judges have gave the feedback to work on the electrical components research also.
How did the changes take place? Like, were you able to meet their expectation and keep on improving upon, or keep taking the feedback and kept implementing that?
As Manan said, after every mentoring session, we got some changes, we got some improvements. Like our mentor suggested us to improve something, or what we are lacking, mentor helped us very in those particular domains. And after every mentoring round, in the next particular round, we expected to make those solutions which our mentor suggested in a very seamlessly way and improve in, like every domain they have told us. As Om can continue after.
Yeah, so the first round was, if I'm talking, so in the first round, the mentors were telling us like we need to work on the electrical components because all of us were from CSE, as Manan said. So after the first round, we dig deep into the electrical components, and in the second round, we amazed them actually by how well we were prepared for the questions which they were asking, and we studied well all the electrical components which were in the substation and the relations as well. We also made a diagram and the circuit diagram for the substation as well and showed them, and they were generally impressed from our performance. And in the second round, we also like showed them the complete website. So the overall journey was like very good, and the mentor was very supporting as well. They guided us, and we also reached them out that we were having some problem regarding this and that, and they guided us a lot. So the overall like SIH building journey was very amazing. Yeah.
Okay, great. Good to know that. And of course, no wonder you went on to win it. The judges must have been really impressed by the progress that you made. So now tell me, where do you go from here? In the sense that now you have the knowledge, you have the capability of turning that into a viable innovation. So how do you want to use this knowledge and innovative spirit of yours further in your careers and life?
I think like coming from CSE background, if we were able to achieve so much for in electrical related projects, so I think we can work upon this more. And I think I would like to like make this project more and like support government actually with this project if possible. So yeah.
We are making it in a big scale so that government and as well as working side which are dealing with those problems on daily basis, they get some help from our side, and to do that we are going to make it as good as possible. So
Okay, great. All the best. My best wishes are with you to not only get this project to a very successful level, but even further on, keep developing such innovative ideas and platforms so that we can all, as a society, as an industry, benefit from all of it. Thank you so much for joining today and sharing your project with us. And we wish you the very best for your future. Hope you'll be continuing to innovate and enrich this country with your knowledge and your power of imagination. Thank you so much.
Thank you, sir.
thank you so much, sir.
By enabling real-time insights, predictive maintenance, and smarter decision making, this innovation can pave the way for a more reliable and resilient energy ecosystem. Thank you for joining us on this insightful journey. Stay tuned for more stories of innovation that are shaping the future and the world around us.